Thank you, Victoria, and welcome to you all to the ITS America Digital Twinning Decoded webinar. I am Tim Drake, and I'm thrilled to kick off today's event with a topic that really signifies a substantial shift in our ability to simulate the world around us, and that is digital twinning, going far beyond traditional digital modeling. Digital twinning has proven to be an increasingly valuable tool in the transportation and infrastructure sector. Its applications are diverse, ranging from traffic management and bridge construction to autonomous vehicle testing. And today, we're going to delve into some of these applications, exploring how digital twins are transforming transportation. Our agenda includes insights into planning, the challenges associated with digital twin initiatives, and real-world experiences from agencies that have successfully implemented these technologies. We will showcase use cases from the ITS America Digital Twinning Decoded document, demonstrating how digital twins can manage traffic incidents, monitor bridge health, prioritize roadway maintenance, and remotely test the joint control of vehicles and signals. Digital Twinning Decoded, which can be accessed at the link in the chat, explains the concept of digital twinning in a practical and non-technical way, and is intended for transportation practitioners and non-practitioners alike. As Victoria mentioned, please feel free to enter any questions you have during today's event into the Q&A function, and we'll seek to answer those questions throughout the discussion. To guide us through this discussion, I would now like to hand it over to ITS America's President and CEO, Laura Chase, to be our moderator. Laura?
Thanks, Tim. Well, welcome everyone. Good afternoon for those on the East Coast. Good morning for those on the West Coast. I'm really excited to be here today with a panel of member experts in digital twinning. As Tim mentioned, in the chat, we've put a link to a document that we released last week called Digital Twinning Decoded. And for those of you who follow ITS America, we've started to do some decoded documents for some of the new and emerging technologies in our sector that might deserve a little bit more plain language treatment and a little bit more explanation of not only what they are, how they can be used, and what benefits they bring. So we're actually going to dive into all of that today on this webinar. I'm very excited about it. So today with us, I'm excited to introduce our panel. I have with us Matt Junek, who's Associate Fellow of Intelligent Transportation Systems at HNTB and was a co-chair of this digital twinning working group that created the document. I also have Simon Zhu, the principal of New Mobility, who actually leads our Emerging Technologies Committee that is part of this digital twinning work. I have Mark Pittman, who is the CEO of Blinksy, and Genus Ko, who's the Director of Product Management at Recore Systems. All of them are experts in this technology and in how we can bring digital twins to transportation to solve some of our most vexing problems. So I'm going to kick it off by going to Matt first. And Matt, I'm going to ask you a very basic but important question, which is, what is a digital twin and how does it differ from a traditional simulation or model? Which, by the way, I read the document, of course, and I feel like this is a foundational and very important question to answer.
Absolutely. Thanks, Laura. And yeah, happy to be here kicking things off. So, what you'll find just as many definitions for digital twin as you will for AI these days. And as part of this Decoded series, which the last one was the AI Decoded that ITS America published, that the point is to really break through the buzzwords and focus on what's truly new and different. So in this world, there have been many advances in modeling and simulation that we've been witnessing for decades. Connectivity to the real world is what distinguishes the digital twin. A digital twin is an evolving model of a physical system that's updated through digital infrastructure, another keyword, to monitor and analyze, in some cases, and optimize changes in the real world. So this feedback loop with the real world, sometimes in near real time, is what makes the digital twin more powerful and opens up more use cases, and what we've aimed and focused our discussion in the digital twin decoded document on.
Right, that's helpful because I think the first time I think I heard the term digital twin, I was trying to remember, I think it was maybe 2017, and I assumed it was just a simulation, right? A simulated environment, but clearly it's much more robust than that. and having that direct connection to the real world and the data and what's happening in the real world is what actually makes it so unique. So Matt and also Simon, I'd invite you to jump in here. Can you give just a simple example that everyone could understand of a digital twin in the transportation industry?
Uh, Sure, I'll start out, and then I know Simon has some thoughts. So, simple idea, and something that many that have been in traffic engineering is, with traffic simulation, and we've been doing that, of course, for years and years. One of the key parts of creating your traffic simulation model is the calibration step, is where you take that, one snapshot in time counts from the road, and you input that into your model, and then you spend hours and hours and sometimes weeks calibrating your model to try to act like the real world and those counts. Taking a digital twinning approach to that, you can nearly eliminate that whole step to try to calibrate to make your model work like the real world by having your model and then bringing in actual data that's happening there out on the street. You can then do, real interesting things like, close a ramp on a freeway, see what that happens in your digital environment. And if you are happy with those results or you know what to expect, then push that change out to the real world, see what happens, and continuously monitor and update it.
So it's really de-risking some of those decisions for you.
Absolutely. It can be seen as another form of a decision support system in many cases.
Yeah, absolutely. Simon, do you want to jump in with another example?
Yeah, sure thing, Laura. And maybe to build a little bit on Matt, I'm actually going to go off in outer space for my use case, and actually going back a few decades because digital twin actually originated in the 60s when NASA first had to use this technology to deal with the Apollo 13 crisis. So a little history lesson here is there was an oxygen tank that exploded in space with Apollo 13. Clearly, there was an impact on the life support and on the urgency with the astronauts on board. And what the mission on the crew did was they used multiple simulators, grabbing both geospatial and telemetry data to evaluate the causes of the failure, as well as create a physical model of the vehicle and play out different scenarios, which eventually led them to developing the fixes that safely guided the astronauts back home. That was actually the incident that prompted the iconic saying, "Houston, we have a problem." And so, since then, clearly digital twin has continued to evolve in different industries, right? Most notably, I think in automotive in the early 2000s, University of Michigan professor, really popularized the term from a manufacturing perspective, which makes sense because at the end of the day, the digital twin allows the speed of iteration as well as the precision for manufacturers to understand all the different components and parts inside of a vehicle, to not only meet performance standards and specs, but also to control costs, right? And today, you're starting to see that same technology starting to play out across different use cases here in transportation, which I'll just kind of give a high level, but then, also maybe save some of the detailed discussions for my colleagues here who are working in those specific areas. But I think if you think about digital twins in transportation, it's all about what kind of problems is it looking to solve in terms of planning, in terms of design and construction, in terms of operations and maintenance. And a digital twin for each one of those project life cycles looks a little bit different, right? So we cover a little bit the space use case as well as what Matt said on traffic management, more from operations. But from a planning perspective, a digital twin maybe looks at geospatial data around a particular city, not only the street network, but also what does the land use look like, right? And how tall are the buildings and what are some of the context and characteristics? Because all of those things affect how people travel and what they're using the infrastructure for. And it doesn't necessarily require real-time data, but certainly does require real-world data to inform some of that decision making.
Well, I love that you took us not only to a different dimension, but like a different galaxy, right? In your example. And I am a huge fan of the Apollo 13 movie. So
Yeah.
I love that example. It's always good to have a good example, something that people can understand and relate to. Um, so Genus and Mark, I want to go to you next about you guys are actually delivering these solutions, your solutions, right? Use digital twins So how are they being used in transportation? In your view, from what you've seen in managing infrastructure or vehicles, talk a little bit about some of the applications where they're being used.
Mark, do you want me to go first?
Go ahead.
All right. So, Laura, great question. So, I prepare a couple of slides to help me better illustrate this. So, let me share my screen. All right. Can you see the screen okay?
Yes, we can see it.
Awesome. So, when we're talking about a digital twin, in the context of traffic management. So basically, this is one of the use case that Rekor is working on and actually leveraging digital twin technologies. The key question we are, kind of the driving North Star is for us is how does digital twins enhance traffic safety and reduce accidents? So for a little bit about Rekor, we are a roadway intelligence company. We exist to basically empower agencies and road users with actionable insights. What it means is like we take in all of the roadway infrastructure data, but also movement data, and fusing it into one single system so we can constantly understand what's going on and then extract those actionable insights and giving back to our users. So we're focusing on like a lot of cases, a real-time actionable insight. Our goal is to help our user really make real-time decisions. And when we talk about digital twin, so we have an application, a platform called Rekor Command. This is our digital twin solution for traffic management. So piggyback on the definition that ITS America come out with, the digital twin that we're looking at it is a dynamic virtual model of a physical system that continuously updates to reflect changes in the physical world. So in our use case, we actually basically thinking about these in terms of the movement objects and the static objects and the relationships between them. So the first is the static objects, like we have road sensors, cameras or traffic lights that is able to send digital signal within the digital twin. But we also have movement objects such as connected vehicle data, movement data, mobility data, and also maybe people that are wearing wearables. And then you have to kind of fuse all those data together to understand the relationship within that ecosystem. And if you do so, then now you can apply, we talk about simulation, but also these can be simulation in real time. But the key is to apply logics and algorithms to really understand the correlations between these objects. And this is where the top layer is what we call the decision support. It's the top layer to actually create that feedback loop back to the physical world in the form of alerts, actionable insights, as we mentioned, and sometimes visual aids, right? We can color code a segment of the road and let you know what traffic is happening, and also recommendations. So this is our context for how digital twin is being used from a Rekor perspective. Now let's take a look at the traffic incident management use case specifically. Traditionally, without the digital twin, how do we detect incidents? We, in most of the cases, relying on public reporting. These are people spotting a incident happening on the road, they're calling 911 or calling into the traffic hotline. And so this is kind of reactive, right? Like you have to have something happen on the road and people have to see it first, then they report it. So there's a kind of a delay detection, if you will. In some cases, in large metropolitan areas, we would have TMC put together where you actually have a staff operation to monitor your roadway in an extensive period of time. But some of the cameras may be too far away, and let's face it, humans do make mistakes sometimes. Now, in a more advanced use case, we have road sensors embedded onto the road to trigger, data anomalies, but it's not 100% of the rows being covered. So it's limited triggers, if you will. After all, like many instances actually with the traditional methods will go undetected. Imagine there's a elderly person stranded on the side of a busy highway changing a tire. Now, this incident is unlikely to be reported through 911. And some of the cameras, as I mentioned, is too far. So even though the camera is able to see the part of the highway, but it may not immediately spot that incident. And it's also unlikely to trigger the road sensor in this case, right? So this is still an incident and it's quiet, but dangerous. It can easily cause a secondary crash. How we do it? We basically have a digital twin solution. It's AI driven in incident detection. So the benefit of using an AI and then fusing different sources of data to detect incidents, first, you're kind of covering a much larger side of the roadway, right? And you're able to also correlate the data from infrastructure data to movement data, as we were talking about earlier. It's almost like having a nervous system being put on your roadway. Any part of the road that you cover and it touches, we can detect it. So we're taking away that detection delay, or at least like strengthen the delay down much significantly. And so faster incident detection means faster response to those incidences. So going back to the strain that elderly person changing a tire, that actually it really happened. So this is one of the incident that happened on our customer's roadway. Our system detected a stopped vehicle and its location, then alerted the operator. The operator looked in the CCTV and at first didn't see that person, but our system was giving, additional insight. We're giving them, hey, the persistence score is still high, we're certain that there's something on the road. Then the operator looked into multiple CCTV, zoom in, and sure enough, he saw the incident, on the side. So that person is able to dispatch a FSP quickly and help that person and then prevented the accident from happening. So I would say that's an anecdote for how digital twin can be applied and be very beneficial. But also there are other benefits to it. So as we mentioned, I mentioned that we have faster incident detection. This is from all of the data that we capture from our customers. We are on average 8 minutes faster in our incident detection. And that translates into average 45 minutes clearance times reduction for our customers. But also the system is always on, right? We're not only detecting the incident and letting it go, we're also storing those data. Then the data is able to help us train our AI model. Now we can then create, predictive analytics to help our users spot those incidents before it happens, such as crash risk or a hotspot, etc. Another benefit is enhanced communication. With such a system, you can easily integrate other agency system or even have your public communication automated. So everyone is pretty much getting the same information in real time. So after all, what we're looking for is safer roads and fewer accidents. Our system has proven that we have helped our customer reduce 29% of secondary crash. So there you have it. That's one use case for you to consider.
That's a great use case, Janice. Thank you so much. I'm very familiar with that use case. I love it. I think it's very compelling. I love the proactive nature of what this digital twinning solution enables for agencies. And if you're not already in the DMV, particularly on the Beltway in DC, I really hope that you guys can work with the local agencies there to help predict and clear crashes faster. It's a huge benefit to the whole traveling public. Let's go to Mark now, because Mark, you have a really interesting solution as well that I think solves, and I think solves a lot of, I'd say, legacy problems in the industry. Would love to hear a little bit about, Blinksy's approach and how your solution's being used.
Yeah, absolutely, Laura. And I'm going to build off the comments that have been made already. Particularly, I liken back to Matt's original comment about how critical digital infrastructure is here in the digital twin piece. And Simon mentioned the specific example on the dealing with hardware deficiencies, right, as it comes to Apollo, and all the tying that all the way down to what happens on the roadway operation that Gina's highlighted. So for us, we want to see the roadway through the perspective of the driver, right? We've all been in the car before. We've noticed, a knocked over barrel on the shoulder, a stopped vehicle, debris in the middle of the roadway, a traffic signal that was out. All of these things that we as humans intuit every day very simply and easily, using the eyes and our cognitive function to make sense and understand. We're moving into a new world, a digital realm where vehicles are starting to try and mimic what the human does every day. So far, not quite at the level that we can do, but in some ways better, right? Because repetitive tasks become really challenging for us. And we think there's a really unique synergy and opportunity here to feed digital infrastructure data into these digital twins and use AI to support decision making and really generate value for the end user. Gina's highlighted some critical examples here for traffic operations, but for me, I'm really passionate about the infrastructure itself because I think it goes unnoticed, right? We take it for granted. And just think about the trillions of dollars worth of infrastructure we have in the United States, whether it's the roadways, the pedestrian bridges, the rail lines, the even simple things like painted sidewalks or bike lanes on physical asphalt roads today. These become really, really, really challenging things to manage. In fact, if we look at our state DOT budgets, the majority of our money is being spent on the maintenance operations. So that's where we focus our intelligence. And we did it in a unique way. Harken back to the kind of 2015 to 2020 timeline, and everyone was talking about how vehicles can talk to infrastructure and infrastructure can talk to vehicles. It was starting to become this conversational focus on how do we bring that digital infrastructure and information into this idea of a digital twin. And again, digital twins have been around for a long time, right? We harken back to things like BIM and building models and the design phase, now making those available from paper to 2D to 3D, now into 4D design files that can be made available. We've all seen a video game, maybe where Spider-Man's on webs shooting his way through downtown Manhattan. That's been populated through reality services today that tools like Xbox and PlayStation have made visually available. Those tools exist for our engineers and our designers and our planners today to make sense of their infrastructure as a digital twin, as a digital replication or representation of what's happening, now fed with this digital infrastructure data. So for us, we focused on the vehicle drivers themselves, and we did that in a unique way by partnering with the dash cams inside of the vehicles already on the vehicles today. Over 1.6 million vehicles in our fleet in the United States, on average per day, are driving around, delivering packages at your front door, showing up at the grocery store, delivering those goods and services that we need to continue our way of life. And they're reporting in near real time with HD clarity pictures of the roadway. And we have developed an AI-based application system that makes sense of that. And so what we'll publish here in the link is what this looks like at a digital infrastructure level nationally. So just in time for ASHO Annual last year, we published on our website free of charge for anyone to look at and view a few different representations of what this looks like nationally. So one, we published an example of what all the work zones look like on the Interstate Highway Network in the first week of October. A digital replication and representation of the presence of traffic control devices, right? That systems like Rekor could use to ingest and make sense of what's going on, that human drivers could use through feedback loops like Google Maps or Apple Maps, or autonomous vehicle systems could use to make sense of from a digital infrastructure perspective as well. All of these things tie back together. And I think that's a really, really crucial thing, both on the digital infrastructure side and ultimately the digital twin side. Things have to be interoperable. No one person will own all of the variables or control them, nor should they, because the future is an open ecosystem with open APIs and open standards where new things will evolve and grow and control. And we see that really as the future of these opportunities to continue to participate and grow. But for us, it's this insight-driven intelligence that's really crucial. So take an example, one of the data layers we published is all the guardrails on the Interstate Highway Network, which is millions of miles of guardrail. And now you might ask the question, okay, which guardrails are out there that are damaged? Now you've identified, a subset of those that are millions of miles that are damaged. Now, of those, which ones are so severely damaged, they might not deflect a vehicle back onto the roadway if a vehicle hits it, right? How do we focus our time and attention, the limited resources we have, the reduced manpower that we have in our agencies today to tackle the most critical needs at the top of the list in the most specific ways possible? That's what it's about. It's providing these insights. It's delivering that in an AI-based application. It's about enhancing the human to do a better, faster, smarter, greener job. And ultimately, that's, I think, what we're all after.
Thank you, Mark. Yes, I love your example about guardrails, right? I love the example of how this can really help our human workforce understand what needs my attention and where can I put these investments in the places that they're actually needed most, and be able to triage, some of the, just hundreds and hundreds of maintenance requests and needs that any agency would have. You talked a little bit about this, but I just want to ask the panel, one of the questions, which is how do digital twins integrate with other technologies like AI and 5G in transportation? Curious if anyone wants to tackle that answer.
Yeah, happy to take a stab. So, actually, Mark, as you were talking about digital twins being used for AV deployment, I was watching a Waymo drive by my window here in Atlanta, Georgia, where they're, starting to do kind of the early phase of testing. But that's certainly a very prominent example of digital twin use today, right? Is for, AV testing. Specifically, the amount of miles that an AV needs to drive before it's considered safe, right? I think originally, a few years ago, RAND had a report that said you need to drive 8 billion miles or something close to that in order to kind of meet that threshold. Well, Waymo's actually driven, according to their own website, 20 billion miles, so 3 times that amount almost. And they're serving 150,000 trips a week across multiple cities today. And so I think it's certainly a very exciting use case, but it's the reason they're able to do that again is because digital twin, right? Because you're able to generate that synthetic data that allows it to the algorithm for AI to be trained on in a much faster and more cost-effective way than having that car drive in a real world condition, right? And to your point about using, I haven't actually had a chance to dive into the Blinksy solution yet, so we'll love to have a chat after this. But, that's also another great example of, just using AI, computer vision, machine learning to collect the roadway asset data to inform, from an asset maintenance perspective. But then also that same data can be useful for a planning perspective, right? For instance, like understanding not just the guardrails, but also what does the signage look like, and to have the MBTCD compliance reports that some of these agencies have to deal with, right? Those are all very useful and helpful use cases that deliver practical value to agencies today with technology that's available today, right?
Yeah, maybe I can also kind of harken back to a comment that Genus made earlier, that kind of ties to Simon's points in here, which is, at the end of the day, we need access to the data, right? This example where there's multiple CCTV cameras, you've got to zoom in on them. Without connectivity, we're lost, right? So whether it's the 5G network or 4G today, whether it's the broadband and fiber networks we have in place, or even our satellite communications, those are really crucial. I mean, we deal with a fleet of vehicles that are constantly transmitting in near real time gigabytes upon gigabytes of HD video files, and now we're dealing with scenarios and where we have users and customers who don't have connectivity, right? So we deal with remote areas in Alaska, for example, or disaster environments. We're working with our customers to identify if we can use Starlink or satellite communications to transmit this in real time. Why? Because at the end of the day, if you can't get the data out, you can't make the data useful. And that really kind of hits on these three topics here, which is, AI is necessary to scramble through the massive amounts of data we now have because everything is connected. Without connectivity, the system falls apart, but it's only possible because we can use computing to aggregate all that data into one place and make sense of it. So really, those are the three foundational pillars on which we build these technologies. This digital twin representation of the real world is connectivity, the intelligence, and of course the databasing and computing to make sense of it.
I'll just add one more quick kind of use case or example that again ties all of those things together, and somewhat on behalf of Greg McGuire, who wasn't able to join us today, but as managing director of MCity, he's would be very proud to show off this example. So, University of Washington partnered up with MCity, so about 2,000 miles away, across the country, to help advance the research and the work they were doing on joint control of using connected vehicle data for traffic signals. And so their research and their training algorithms on using actual data, coming from vehicles, trajectory data and such, as opposed to how we would traditionally do adaptive signal control with just sensors at every intersection or mid block, infrastructure based. However, there are a lot of risks and challenges in testing these things out in a real environment when you're dealing with signal control and what could go wrong, or even just the frustrations if you lock up a signal during rush hour because you needed a lot of vehicles to test it out on. So MCity, if you're not familiar with it, is a kind of a testing proving area where they have roads, signals, a lot of infrastructure for manufacturers and vendors in the transportation technology space to go out and try and develop their things. They created a digital twin and a virtual environment of their physical environment. So University of Washington was able to remotely log in, feed the information into the actual signal controllers out there, watch on cameras, have some actual vehicles drive around to be background vehicles, and then load in various penetration rates of connected vehicles to see how that affected everything. So they're able to do some on the ground testing it 2,000 miles away, where they didn't have their own facility to do that testing or whatever. So that enabled them to train their algorithms, their AI models that to do this kind of work, as well as it required that intense connectivity between everything to be able to monitor and push and do everything in near real time.
Yeah, Matt, thank you for mentioning that. I was going to mention on behalf of Greg, who was our other co-chair and is unfortunately sick and couldn't join us. But I was fortunate to be at the launch of MCity 2.0, which is the launch of this digital twin environment. And it really is fascinating. It's first in the world to be this open sourced environment, and it also allows for this mixed reality testing and simulation. And I actually had I was able to actually do that. So I was able to, whether I was only, 100 feet away, but whether you're 2,000 miles away or 100 feet away, I was able to actually, in a simulator, drive an actual vehicle with an actual, people in it at the test track within a simulated environment. So it was just like a really interesting experience. And it's great for, as you mentioned, for, research, for testing, for, being able to understand the impacts of some of these changes or theories that you have that you need to test in a safe environment. And so, yeah, I just want to put a shout out to MCity for that product. It's and they are accepting applications for researchers who want to be able to use that environment. Just so everybody's aware.
Laura,
Let's
just
talk a little
really
bit.
quick, I
Oh,
just
go
wanted
ahead.
to
Yeah,
add, like, all these dialogues is reminding me, I also have another example of the benefit of using a digital twin. Yes, the connectivity to the devices and infrastructure is still required, but one of the benefit is much better communication, right? Like we heard from our customer, like during COVID, they are TMC operators and operations, and they have their whole setup and CCTV hooked up in one system, but the next day they cannot go to work anymore, right? Because of COVID, everyone has to stay home. But luckily, they have a system like a digital twin where you have the entire infrastructure digitized, where it's web-based and you can leverage the connectivity to continue operation remotely. So I think that's a huge benefit.
agree. I think so too. I do want to say, so if you guys, if you attendees have questions, go ahead and put them in the Q&A box. We are going to get to them in just a little bit. I see a couple in there that we will address. But before we go to the Q&A in the chat, I do want to ask the panelists, so we kind of defined out what is a digital twin, right? And what makes it different from just a simulated environment. What are some common myths or misperceptions about digital twins in transportation that you have heard? And how can we address them?
And maybe I can address one of them. From a misconceptions perspective, I think everyone is still a little unclear on what a digital twin will look like in their work environment at total scale, right? We all have pieces and parts of this, right? And I like to go back to the design piece because that might be the part that a civil engineer in particular is most familiar with, right? The design piece and this idea of having a 3D digital rendering that you can review and look at in different pieces. And there's various other examples of this, right? Google Street View has been publishing imagery of our roadway network across the world for years now that we've come to rely on. And what does it all look like at the end of the day? Is it ever going to be done? Is there something tangible, or is this a pie in the sky idea? And I think that's really what it kind of comes down to, this misconception that we're always 5 years away from a complete digital twin. I think digital twins exist today. They may not exist for the entire transportation system or the entire infrastructure system completely connected to each other, but I think that's largely also based on the fact that open standards and systems have been permeating the industry, but are not quite fully there, right? And that's also, I think, largely on our agencies to write their procurements in ways to ensure that our technology standards are compatible with each other, to get our vendors to work with each other, and to also build technologies. I mean, there's really compelling new technologies like Cesium that allows you to bring in multiple different data sets into one place at one time and create these 3D models, Esri, and many other tools. But I think really that's the biggest misconception in my mind, Laura, is that we're not there yet, or always a ways away when these tools exist in a variety of perspectives, but they'll always get better.
Always evolving, always improving.
I would agree with what Mark said. And I would also add, when people typically prepare for these conversations about digital twins, like there's usually like a common image I see is like someone wearing like an Oculus VR headset, and it's like digital twin, right? And that's like, okay. But then, to Mark's point, it's like there's so many different ways to access digital twin technology. And to the example about Google Maps, like I don't know if you guys have checked your Google Maps recently, but in some cities, like they've already used Gemini and their Gen AI, which is their Gen AI model, right, to create that 3D rendering of the map. So like the other day I was here in Atlanta, I was texting in the navigation to a place I was going to. It's like, oh, cool, this is like a new feature. I didn't, here's my house, here's what it looks like. There was some blobby shapes around it still, so it's not perfect, right? But you can tell like to the point, the technology is evolving very fast, and it's becoming more and more accessible. I think that's ultimately what you want, is to make it more accessible and to democratize access to a lot of different users, to give them the information they need to make decisions, whether from a transportation planning, engineering, from a professional perspective, but also from a road user, right? If I have a digital twin that helps me make a better decision about how I use the infrastructure, then I would certainly want that tool available.
One other kind of misconception or something that could be viewed on digital twins is that this is something brand new, or it only applies to large scale high budget projects. And while there are large scale and entities with seemingly endless money to be able to do things, it also can be done at much smaller scales, from just the trying to do what, again, I go back to that traffic simulation use case of signal timing for one corridor, something like that. Having the cameras and sensors that are already out there today is likely enough infrastructure already there to be able to collect the information. And so that's something that is smaller scale and can be done today. That is not a crazy future, needs quantum computing type of thing. And so it's here, it's real. And to go back to, kind of Simon's, introductory remark, it's a bit newer to us in transportation, but the idea of having a digital representation of your physical assets and having connectivity between there to monitor, plan, maintain, optimize has been around in manufacturing and other industries for a long time. And so there's definitely a lot that can learn. There's the Digital Twinning Consortium that's out there that deals across many industries that has a lot of great use cases outside of even what we are talking about here.
Great. Let's talk for a minute before we get to some of the questions. This is actually in one of the questions that was in the Q&A. Talk a little bit about what are some of the biggest challenges to implementing a digital twin in transportation. And I'll open it up to whoever wants to start.
Yeah, maybe I'll jump in again real fast. I think the biggest challenge I see is you've just got to get going. There's no perfect recipe to start, and you've just got to jump in somewhere. And oftentimes, if you're in the agency level, one of the simplest ways to do this is to look at your construction process, right? You're doing lots of construction projects. You've got lots of opportunities to test out innovative ideas. You can work closely with FHWA and others to do this. But it doesn't matter which area of the organization you're in. When you're in something like maintenance or traffic operations or design, any area of the infrastructure piece is an opportunity to do this, and you just got to jump in and get your feet wet. Why? Because this is iterative. And you've got to understand what the benefit is to you specifically. So find a specific problem that might be useful to you. An example, on the Blinksy side might be guardrail damage, right? Where's our guardrail? How much do we have? How much damage is there? How do we prioritize those responses and see if there's a solution for that? And try that for something else and just get going.
Love that. Yep.
Yeah, I would also add, I would also add just real quick that there's discussions similar in the AI space too, which is like you need to have like a certain set of steps completed. You need to have data governance plan. Maybe you need to have someone who's a chief data governance officer, et cetera, et cetera. That could be true, right? But it doesn't necessarily has to be true in terms of like having the perfect plan before you get started, because to the discussion earlier, right? It's like this technology continues to evolve. It's not static. It evolves not on an annual basis, but on a monthly basis. So have something that is generally agreeable to your agency and obviously has the right safeguards and the risk mitigations, but you just got to get started and try, because only after you get started, you actually know what's actually relevant for your agency and for your specific context. And I would also say that the other big challenge that I've heard is just what is the ROI, right? What's the ROI? As well as being able to communicate that ROI to decision makers who might just be exposed to the technology, but then, the actual quantitative aspects of the digital twin is a little bit squishy, which is kind of what I like, earlier, Genius, about your presentation, because you kind of went through, here's some specific use cases, but then here's how, here are percentages of how we've improved traffic flow, for some of our agency customers, right? So being able to communicate that, I think, is also important.
Yeah, the RI piece is exactly what I was trying to bring up. So Simon, thank you. Yeah, exactly. So that's the kind of resounding message that we heard from our customers. Like, yeah, we love your solution, but how can I justify it? So if there's a way for we are helping our customers justify through the metrics that we are able to generate. So I think there's an opportunity to help standardize maybe some of these ROI that agencies should be looking for, and kind of leading them into thinking about why some of the metrics have it's valuable and how it's helped the agency. I think some sort of guideline would be super helpful.
So I'm going to pepper in a question or two from the Q&A. So tied to this question of, what are some challenges? There's a question in there, which is like, what is one thing that a DOT could do to advance, advance using a digital twin? Let me see to advance these efforts. So anybody have any thoughts on one action, one thing a DOT can do to advance this?
I will just throw out to say a focus on data governance. It came up before, but there's like every other thing you use for data driven your decision making, it's garbage in, garbage out. And so if you don't have quality inputs to your model, you might have a model, but then what you're getting out of it is not going to give you the answers you want, or not give you accurate answers at least. And so that's at least one thing to start at, and then that can help enterprise wide with many things. But certainly, if you're using that for trying to get an output from your digital model, you're going to need to make sure what you're putting into it is worthwhile.
Maybe to piggyback on Matthew's comment here, on the part of the data governance side is how to make that data available. And I think that's a really crucial piece. So I look at a traffic operations center, and I look at public information sites that the government agencies put together, and we display all sorts of information. You can see live CCTV feeds, you can see construction zones, you can see congestion, snow plows. A lot of that information is available online. It's oftentimes not available as an API to be consumed by other parts of the system, right? So there's a really good example that part of the data governance organization is thinking about, great, we're going to make this data available to the public, but how do we make it available to anyone in the public? How do we make it available for any other technology, any other application? How do we make sure that data can be aggregated and consumed in the tools and technologies that our customers might be using today?
Yeah, I would say add to what Mark just mentioned. Another thing to think about is actually prioritizing your investment in digital infrastructure, because I believe if you incentivize the effort, then there's traction, and we can do anything. Like as human, we're very creative, and we can tackle any problems. But with the right incentives, is super important so that you have the focus and the will and the support to do what it needed to be done. So prioritize investment.
Yeah, I would say, think about the problem and the use case you're solving for. Do a market scan of the digital twin technology that's most appropriate, right? Is it an asset management problem that you have, or is it a planning problem, or is it a traffic operations problem, right? Because depending on those, you might be talking to Genus, you might be talking to Mark, you might be talking to someone else entirely different. And then I would say you can always do a pilot demonstration of a digital twin, because you do that kind of in a more closed environment internal to the organization. And what it does, to Mark's point earlier, is it allows you to actually try it out, understand what data you actually need to make it work, as well as what data you need to make it scale. And having that information would probably be helpful to develop a more robust data governance plan than trying to start with a data governance plan with kind of a academic approach to what I think I need, but perhaps disconnected from the realities of what the data environment actually looks like.
Yeah, and I love how that feeds into this iterative approach, right?
Yeah.
That we've been talking about. So a question in the chat that I'm hoping someone might be able to answer, right, is from a cybersecurity perspective, what are the challenges digital twins do face or can face in the near future?
Yeah, at Recor, we think about cybersecurity a lot, because these can be sensitive data, and we are accessing a lot of data sources, and then we're processing it in our own environment. So this is top of mind. That's why we wanted to go with very strong partners, such as we're on AWS, and we're partnering with NVIDIA. So having good, very strong industry-proven partnership is also very important. Another thing I would say is that we just passed our SOC 2 audit, and we got the certification. So having your organization always looking for way to keep up with the cyber security front, and also updating your infrastructure is super, super crucial. So this is ongoing, because you get smarter, the hackers get smarter. So it's a ongoing effort, but this is top of mind when we're talking about digital twin.
One of the easiest ways, Laura, I think, to think about cybersecurity is to think about what happens if you do get hacked, or the data does become available, right? And so we focus a lot of our attention on the preemptive, which is making sure there's no PII, making sure there's no sensitive information, making sure that that's not even available in the data set, even if it does become compromised. Or if a data set does become compromised, how is it compartmentalized in a way that not everything becomes connected, right? So let's say you could disassociate every single letter of someone's name into a separate database. Someone gets access to one database while they get a bunch of A's, right? But they're missing the M's, the R's, and the K's to spell the full name. So those are really, I think, simple opportunities here, and a lot of that comes down to the technology itself. So, looking at things like removing the PII from the information before it's used, we do that on the imagery side, making sure license plates are blurred, faces are blurred, making sure reflections of license plates and faces in rear view mirrors, the side view mirrors are blurred, right? Really challenging things like that are really simple ways to get going and tackle the cybersecurity problem, because ultimately at the organizational level, you've got to think about this from the perspective of not if you're going to get hacked, but when you're going to get hacked, what would that lead to? And that's the easiest, I think, framework and lens to put on that.
Yeah, I would say, cybersecurity issues tend to gravitate towards theft of customer data. That's always top of mind for any product or technology company, and in general, and rightly so. But I also think there's a specific way in the digital twin space which cybersecurity affects it, which is this concept of data poisoning, right? Which is when hackers inject malicious code or corrupted data that affects the algorithm of how digital twins work. So like, to use an example, like let's say, you have a robo-taxi that is trained on simulated data of what the roadway conditions look like. Well, if you corrupt that data, then the passengers who are using that robo-taxi might be affected in terms of how it operates on the road, and perhaps turning on making a left turn on a red light instead of stopping, for instance, right? So
yeah. Well, and as you all know, being ITS America members, right, we always refer to the NIST cybersecurity guidelines and encourage industry to follow those best practices and prioritize cybersecurity as we are in a much more connected and digitally driven ecosystem. Okay, another question from the chat. This is broad. How would you create a digital twin for an entire city, including geospatial / buildings / roadways, right of way, etc.? Do you need to purchase the data from Google Earth and import it into a system like Rekor? Anyone want to take that one?
So I guess I'll start. So this is actually something that the US DOT is currently working on a program called Complete Streets AI, which is attempting to create just such a digital twin, of cities across the US that captures the geospatial data, the roadway network data, the land use data, road user behavior data in terms of cars, people, bicyclists, et cetera, right? And the whole idea is when you're developing these streets, it takes such a long time. Part of it is, process inefficiencies, but also a lot of it is data gaps. And so, this is where I think AI combined with digital twins can really make a difference. And I think the US DOT also mentioned in some of their, I think there was a webinar last year by Robert Hampshire and Ben Levine at the time, on AI and transportation moonshots, right? And this idea of like a national transportation observatory. But the whole idea of that is so that cities who are planning and developing projects can access the data they need to kind of move forward. A micro example of that I think is really interesting, and you guys can look it up, is NCT COG, which is the NPO for the Dallas metro area. They've developed, they have I think what they call is like a spatial data marketplace. So basically NCT COG works with mobility data vendors and geospatial data vendors on kind of a bulk purchase basis. They basically get LiDAR data, geospatial data, kind of the 3D, isometric data or orthogonal data, excuse me, of the entire Dallas metro area, right, on an annual basis. And then if you're a city or a contractor working with the city, you can go online and purchase the data on a tile basis. So like you can buy like LiDAR data for like a single tile, which is like about, I think like a block, of a city street, for like $50, right? And so like that makes it a lot more accessible to the public agencies who are often faced with, these awesome challenges, but obviously working with limited resources. So again, making that data availability, through both technology as well as innovative business models on the public sector side, I think is the direction that I'm encouraged by as we continue to move down this road.
So there's
Yeah.
a couple. Oh, go ahead, Mark.
I was just going to add very quickly, Laura, to Simon's point here, I think you can get started very, very inexpensively, right? I think that the barrier to entry is pretty low here. Tools like Cesium in particular have made it available to bring in other data sets. Google Earth is in itself of itself a digital twin. Depending on what it is that you're looking for, many of the tools are already available in public. We've published, a U.S. freeways data set from the entire country, free of charge online for certain data sets. There are many, many tools already available in the public domain. I believe I saw recently on LinkedIn that Tokyo has published a LiDAR data set of almost an entire area of downtown Tokyo free of charge. Some of these things already exist. There's a large developer community that supports this ecosystem. QGIS and other tools have been developed to really support this. So there's a low cost of entry, but you may have to buy data sets to really enhance it to get what you're specifically after.
Yeah. So we're coming up on time, and I do want to ask one final question to the panel. I will say there's a few questions in the chat we haven't fully gotten to. One of them talks about, how do DOT customers think about price versus value of systems that leverage digital twins? And my short answer to that is going to be, if you can show a DOT that you are going to save them money, right, and that they are going to get, if you can actually show that return on investment, I think that is going to be a compelling argument to them. But I would say follow up with Genus and Mark and others on this who are, who have DOT customers to maybe understand that better. The last question I want to ask everybody, and I just ask you if you want to answer, please jump in, but just keep your answer short, is how do you see digital twins evolving in the transportation industry over the next 5 to 10 years? So taking out our crystal ball and looking, is there anything exciting or important or relevant that you want folks to know?
One thing I'll point out here, and I answered it in one of the questions, is as things advance more with edge and fog computing, we can, there's still a lot of consternation over big data and how you deal with the voluminous amount of data and all the computing power. And so I see advances using more computational algorithms and things to really be able to combine and get what you need to feed into it. And so we can be efficient with the computing resources and the connectivity that we have. I think in 5 to 10 years, it'll look a lot different how we can take all of this stuff and get it the outputs we really want.
One of the exciting thing that from my end, I'm seeing is we're seeing the generative AI being taken off in the last couple of years, and that's just the beginning of it. Going forward, we're transitioning from like a generative AI, kind of like the artists, you can tell it to create anything, to more a agentic AI model. Basically, we're able to use a large language model to design the workflow that we want the AI to work to our favor. And it's much more controlled, much more precise, and that is a really exciting space. Given that we have all these data coming into a digital twin infrastructure today, like how can we leverage the next generation of LLM model to build agentic AI so that this can be much more robust and much more easy to use from a user perspective? I see the next 5 to 10 years, this is the most exciting thing.
Everything that can get mapped will get mapped, and it will get mapped hundreds of thousands of times more than it is today. I'm really excited, and as a former startup founder, I'm really always impressed and excited by the things that entrepreneurs will find, that they'll do, that they'll innovate around, that they'll dissect. You may remember a few years ago, Apple introduced LiDAR on their phones. And now you can use your phone to measure depth, right? And use your phone to measure objects. And that opened the floodgates for a host of new technologies. Right? You could go to an IKEA app and see what your furniture would look like represented in your house, or digital representation of your furniture. I mean, those sorts of things will really become the standard, the norm, and the mapping of our infrastructure underground, above ground, on the ground, and everything in between will become the norm.
Oh, Simon, you're muted.
I was going to say, on top of agentic AI, you also have physical AI. For those of you who watched the CES keynote by Jensen Huang, NVIDIA CEO, if you haven't watched it, watch it. But digital twin was front and center, and I think it's going to be something that not only helps humans operate better, but also robots, right? As you have over 20 different manufacturers now building their different robots that uses digital twin both to train, but then also to interact in the real world environment. And that is certainly in the next 10-year horizon. So very excited about that. And, I'm sure Laura has some of her personal comments as well, having, traveled to CES this year. So.
Well, I got to see a robot bartender. So yeah, no, we're going digital, right? We need to be able to leverage AI and use it to augment the workforce that we have today. I think that the next 5 to 10 years are going to be truly transformational in terms of digital enablement and, as you mentioned, advances in generative AI, among other technologies. And I'm excited for it. So I want to thank all of you so much for your comments, for sharing. And we will certainly make sure that we follow up on any questions that did not get answered today. But thank you all for joining us today. And please take a moment and read our digital twinning decoded document for more information. Thanks so much, everyone. Have a great day.